This question is the Edexcel June 2024 Level 3 GCE Pure Maths Paper 2. Question 15. The question says, the curve C has the equation x plus y cubed is equal to 3x squared minus 3y minus 2. A. Find an expression for dy dx in terms of x and y. The point P with coordinates 1, 0 lies on C. B. Show that the normal to C at P has equation y is equal to minus 2x plus 2. C. Prove that the normal to C at P does not meet C again. You should use algebra for your proof and make your reasoning clear. So for A, I have x plus y, all that cubed, is equal to 3x squared minus 3y minus 2. So I'm going to use implicit differentiation here. So I have 3 brackets, x plus y raised to the power 2, and I'll differentiate what is inside the brackets. And so I'll write it as differential of x plus y. So that will be equals to, if I differentiate 3x squared, I'm going to get 6x. And if I differentiate 3y, I'm going to get minus 3 dy dx. So then I have 3 brackets x plus y squared. Then if I differentiate what is the brackets, I'm going to get 1 as the differential of x plus dy dx. And that's the differential of y. So that is equal to 6x minus 3 dy dx. Now I'm going to expand these brackets over there, but I'm going to leave the 3 outside. And so if I do that, I'm going to get, and I have x plus y all squared times 1. I get x plus y squared plus x plus y all squared times dy dx gives me x plus y all squared times dy dx. So now for the right hand side, I can factorize 3 out. And so if I do that, I'm going to get 3. And I will leave 2x over here minus dy dx. So if I divide both sides of the equation by 3, I'll be left with x plus y squared plus x plus y all squared dy dx equals to 2x minus dy dx. So I'm going to bring like terms together now. So if I do that, I'm going to get x plus y squared dy dx, and that is this term here. And I'm bringing over dy dx, so I'm going to get plus dy dx. That will be equals to 2x minus this term, which is x plus y all squared. So dy dx is common. If I do my factorization, I'm going to get x plus y all squared plus 1 times dy dx. And that is equal to 2x minus x plus y all squared. I can now divide both sides of the equation by this coefficient of dy dx to get dy dx. So if I do that, I'm going to get dy dx is equal to 2x minus x plus y all squared, all that divided by, like I said, the coefficient of that, of the dy dx here, and that will be x plus y squared plus 1. And that is the required answer for the A part of the question. So for B, the point P with coordinates 1, 0 lies on C. Show that the normal to C at P has the equation y is equals to minus 2x plus 2. So when x is equals to 1 and y is equals to 0, dy dx is equals to 2 minus 1 plus 0 over 1 plus 0 plus 1. And this is using the derivative that we got from A. So we're just substituting the values of the coordinates. So if I evaluate this, I'm going to get 2 minus 1, which is 1, over 1 plus 1, which is 2. So we can conclude that the gradient of the tangent at P is equals to a half. This means that the gradient of the required normal is equals to minus 2, which is the negative reciprocal of the gradient of the tangent. But the gradient of the normal can also be written as the change in y over the change in x. So I can write y minus 0, which is the y coordinate here, over x minus 1, which is the x coordinate over here, is equals to minus 2. So when I rearrange it, I'm going to get the equation required. So I'm going to get y is equals to minus 2 times x minus 1. So therefore y is equals to minus 2x plus 2. And that's the proof required. So for C, it says prove that the normal to C at P does not meet C again. You should use algebra for your proof and make your reasoning clear. The point of intersection of the normal and the curve C occurs when we solve the equation of the normal, which is this one, and the equation of the curve, which is this, simultaneously. So that would be their point of intersection. So we are going to solve this equation and that equation simultaneously by substitution. I'm going to substitute the value of y, which is minus 2x plus 2, into this equation over here. So if I do that, I'm going to get x plus y, which is now minus 2x plus 2. All of that cubed will be equals to 3x squared on the right hand side, minus 3 brackets, minus 2x plus 2, which is this one here, and then minus 2. So if I simplify this one, what's in the bracket, I'm going to get x minus 2, which is minus x plus 2. So if I write that as 2 minus x, all of that cube, that will be equals to 3x squared on the right hand side plus 6x minus 6 minus 2. So I'm now going to expand this using binomial expansion. So if I do that, I'm going to get 2 minus x, all of that cubed, is equal to 8, which is 2 cubed, minus 3 times 4x plus 3 times 2x squared minus x cubed. If I simplify that, I'm going to get 8 minus 12x plus 6x squared minus x cubed. So now I can replace 2 minus x all cubed with this. So if I do that, I'm going to get 8 minus 12x plus 6x squared minus x cubed is equal to 3x squared plus 6x minus 8, which is minus 6 minus 2. And I can simplify this now. And if I do that, I'm going to get x cubed minus 3x squared plus 18x minus 16 equals to 0. But we know that this equation, which is the equation of the normal, and this curve meet at one point. And that point is P, which has coordinates 1, 0. So this means that x minus 1 is a factor of this cubic equation here. And so if I do my long division to get the other factors, I have x cubed minus 3x squared plus 18x minus 16 divided by x minus 1, which is the factor. Then looking at x and x cubed, I will get x squared over here. If I multiply this by that, I'm going to get x cubed minus x squared. If I subtract, I'm going to get minus 2x squared over here. And then if I bring down the 18x, I'll have plus 18x over here. Then again, I'll look at x and minus 2x. It means I'm going to have minus 2x over here. Then I'll multiply minus 2x times x. I'll get minus 2x squared and plus 2x over here. So I'm going to subtract again. And if I do that, I'm going to get 16x over here. And then if I bring down the minus 16 over there, I'm going to get minus 16. Then again, I look at x and that. It means I'm going to get plus 16 over here. Then multiply again. This 16 by the factor. I'll get 16x minus 16. And if I subtract again, I'll get a remainder of 0, which means x squared minus 2x plus 16 is a factor. And so now I can write this equation as follows. X minus 1, which is the factor we know, times x squared minus 2x plus 16 equals to 0. So we need to find the factors of this quadratic equation here to find the possible meeting place of the curve and the normal. So I've got x squared minus 2x plus 16 equals to 0. Then to determine even this has roots or not, I'm going to find the discriminant. And the discriminant we know is b squared minus 4ac. So in this case, I'll have b squared, which is 4, minus 4 times 1 times 16. And that will be equals to 4 minus 64, which is minus 60. So you can see that b squared minus 4ac is less than 0. So we can conclude that hence no more meeting or intersection. And that is the solution for this part of the question. Thank you for watching. See you in the next video.